Okay, thank you again. I'm Helen Freeman, the Director of Development here at HGC. Welcome to tonight's Preservation School, presented by Charu Chaudhry, one of our advisors. And while I have you all, I just wanted to remind you that there are still 2 more preservation schools this month. Next week, we'll be doing Preservation 101 on Espanol. And on the 29th, we'll be doing a presentation called Landmarked, Now What? With Dr. Keith Taylor. There's also 3 more conference tours this month. The Bowery Boys podcast will be doing 2 podcasts sponsored by HTC later this month. And on June 28th, we have our Grassroots Preservation Awards. So with all of that being said, I will turn it over to Charu.
Thank you, Helen. Just some testing. Can you see my my screen? Can you see my screen?
Yes, we can see it. Thank you.
Okay, awesome. So, hi everyone, good evening. My name is Charu Chaudhry and I will be talking to you about the issues related to construction activities adjacent to historic properties. A little bit of info about me. I'm a registered architect and a vice president at Thornton Tomasetti. I have a bachelor's degree in architecture and a master's of science in historic preservation. My work is focused on restoration, renovation, and preservation of historic buildings. I have structured this presentation to talk about a general overview of the major issues and an overview of the solution strategy, how to get consultation, produce effective communication, and conduct documentation, the common risks and protective measures, handling vibrations and movement, the issues arising from water present at the site and possible dewatering of the site, the issues of fire and safety, physical impact, the importance of designing a monitoring program, and some overall conclusions. Now, valued for their ability to convey the past through existing materials and features, historic buildings must also survive in the ever-changing present. That change is often characterized by new building or demolition activities on the neighboring site. In either activity, physical damage to adjacent historic building may occur. Here is an example of the Dickey House. It's actually called as Robert and Dickey House. It's a 4-story, early 19th century, unreinforced masonry building in like lower Manhattan. A rare representative of federal style of architecture, as you can see. The building is a landmark which was integrated with a new high-rise built in place of a demolished adjacent structure. The photograph on the left shows the pre-construction, pre-new building kind of scenario, and this is the final product on the right. Now, since the damage can be of varying degrees and could be either isolated at some areas or can cause a large-scale damage throughout, various temporary protection measures are often implemented to facilitate the new construction. For example, here, there is an isolated stabilization effort on the left side photo and a more substantial stabilization kind of prepared and a temporary support system prepared on the right side photograph to restrict further damage while the construction takes place. Now let's look at some major issues that can occur, and this is by no means an exhaustive list of all the defects that can happen, just some major, very alarming ones. The construction activities can cause cracking and deformation or bulging in the adjacent building that's shown here. Again, this is a more severe case, and I actually kind of sat in a presentation a couple of years ago that was presented by Department of Buildings, who kind of takes really special interest in this in this topic, and of course, like they kind of have seen a very severe case like this. Cases like this are rare, but definitely can occur. If the impact of deconstruction is more intense, then it can cause movement or worse, collapse of the components of or larger sections of the existing construction. For example, here in these photographs, the roof slab was removed from an existing building, which rendered the walls unstable and splayed and deforming outward. The protection measures are installed, but as you can see, they were not adequate enough to kind of prevent the splaying and the cracking of the walls. And the results could have been even more catastrophic had these measures not been installed on the building. Now let's look at some possible solutions on how to handle this kind of situation where there is a new building, an existing building, there is a team for the new building, and a historic property owner, how to kind of handle this this kind of activity. As we can imagine, an effective planning and protective measures initiated before construction takes place can prevent most of the damage that may occur to adjacent historic buildings. Depending on the nature of the project, protective measures may be limited to documenting and monitoring the historic structure, or may encompass a more broader plan that includes encasing doors, windows, or even an independent review of the excavation procedures and a range of other precautions. Providing adequate protection kind of involves following steps. It's the consultation between the historic building owner and the development team, the documentation of the condition of the historic building prior to adjacent work, which is called as a pre-construction survey, implementation of protective measures at both the construction site and the historic building site. And this could be a part of a bigger monitoring program, which kind of involves a regular monitoring during the construction activity to identify damage, evaluate the efficacy of the protective measures that are provided in place, and to identify and implement additional corrective steps should anything or any issues occur at the site as because of the construction activity happening all around it. Now, as we can imagine, cooperation between all parties can help ensure that the construction activity continues without interruption, and that the neighboring historic building is preserved unharmed. The communication needs to identify potential risks, negotiate the changes, and agree upon protective measures. An independent team of engineers and lawyers may become necessary according to the situation. And most of the projects, most of the sites go through something called as an access agreement, where some of these kind of legal issues are written, but also with the help of engineers and professionals who understand the activity and potential risks, some of the technical kind of language can also be part of that agreement between the new construction team and the historic building owner. Now let's look further into the issues and nature of consultation, communication, and documentation, since this is an important aspect of the management of the expectations of the team members of both parties. Consultation provides the opportunity and foundation of establishing a more of a beneficial relationship that is cooperative rather than adversarial between the two or three parties. The scope of the new construction and the vulnerabilities of the historic building needs to be understood completely and proposed, discussed, and negotiated changes to the construction plan that reduces the risk of damaging historic resources should be understood and discussed with all parties on a regular basis, but definitely prior to the construction begins. The goal here is to draft a protection plan. After the access agreements are drafted and understood and all the liabilities and risks are understood, a protection plan is the next step that's prepared by the construction manager or a third party that's hired by the developer of the new building. And then that plan is circulated to the team members and needs to be acceptable to both parties. It is crucial that these discussions take place during the planning stages of the project. Early consultation also affords the possibility to assess the level of insurance coverage, if that is sufficient to meet the specific project risk, and are all the parties kind of insured through this process.
Charu, we're having a little bit of trouble hearing you. Is it possible to adjust your mic or sit closer to it?
Yes, let me put my headphones on. My apologies. Give me a second. I will get myself situated here. Any better? Okay. Awesome. All right. So I want to now talk about pre-construction meetings, what that is, and when does it happen? As the name suggests, that the pre-construction meetings really should happen at the onset of the project, in fact, at the planning stages, which should address several issues. Most importantly, implementation of the steps to protect the historic structure should be discussed. Clear responsibilities of the developer, the contractor, and historic building owner should be established. Such decisions should be listed in a performance specification that accompany agreements between the contractor, developer, and the historic building owner. A walkthrough of the historic building by the development team is also advisable. It should actually happen. Schedules for major works, such as excavation, requirements for material deliveries, site storage, and other use of premises should be discussed really prior to any activity happening, just to minimize any disruption. If in case the level of protection provided is not sufficient, that's for the historic building owner, local building officials through their permitting process can often assist in making changes to the development plans. All the development plans, they need to be filed with Department of Building as well. So if there are concerns that the historic building owner or their team has, that can be communicated directly to Department of Buildings, because their job is to ensure that adjacent properties are protected. And safeguards against maximum vibration levels can also be established in certain cases. Support from neighborhood committees, local nonprofit preservation organizations, independent engineers, and historic districts council, if applicable, can be enlisted to ensure that protection concerns are in fact addressed. Now, what a pre-construction survey provides is a baseline from which changes to the building during adjacent construction can actually be identified, monitored, and assessed. It may be used to substantiate any claims should damage occur as a result of the adjacent construction, or if it's a prior condition prior to construction activity even began. It is advisable that an independent consultant is hired for this task, whether they are hired by the owner or by the developer. Features that need special protection or attention should be highlighted, such as location, width, and orientation of visible defects, loose material, location of previous repairs that may be vulnerable. And really most important is the distance to communicate to construction operations, which kind of becomes really important. In addition to, the foundation type, the age of the construction, the type of the construction, and general description of the building is an essential component of what a pre-construction survey entails. Now let's look further into some common risks and protective measures that we've witnessed through our experience in these kind of projects. The biggest affecting factors are actually two: the proximity of the historic site to construction area and the scope of the new construction, which kind of become variables that are most significant. Other factors that influence the degree of impact are the age, the construction type, structural integrity of the historic building, depth and makeup of its foundation, and its surrounding soil types. These two, I thought, were really good comparative examples of, the scale of the new construction and their proximity to the historic building. In the photograph to the left, which is not in New York City, it's in upstate New York, where the new construction is planned. You can see towards the left side of the image. I don't know if you can see my cursor. It's somewhere here where you can see a excavation of the ground for new foundations. And here on the right, you can see this is the old Robert Ann and Dickey house, where the new construction is planned really just adjacent to this building. So the kind of vulnerabilities that were present at the Dickey house were significantly higher than the one on the left. Other things to anticipate from the owners, by the owners, should be the effects of increased dust, vibration, and the need to protect the property from it, right? Like the photo here indicates that the protection for dust and debris was not installed. This was a peculiar case, but the monitoring of the vibration should kind of also include more protective measures like that. So the windows and the doors and other appurtenances should be protected. The other things are the vibrations that are induced as a result of the new construction activities. The tools and methods used in demolition, such as impact hammers, wrecking balls, pavement breakers, and implosion blasting, they all produce vibrations that may be transmitted to the historic structures. And we will see this more in detail in the forthcoming slides. And now, I'd like to discuss some of the methods of vibration monitoring most commonly used in the construction projects and really why they are so important. So here are two kind of techniques, and some of the early methods to do this, and still one of the most common ones is the placement of crack monitors, which looks like this photograph on the left. This is used to determine whether the existing cracks in the historic buildings are stable or are still experiencing movement, compared with measurements taken during the monitoring phase. Such information can help determine if subsequent movement resulted from work on the neighboring site. More advanced methods of monitoring the vibrations include instrumentation and computation of the data obtained, where real-time data is gathered in the form of graphs of changes. In other words, they are more electronic kind of crack monitors where data is just gathered through real time, and a person does not need to go there time and again to take readings. It becomes more efficient. However, there is a lot of data that it collects. So an experienced professional is required to interpret the data that's being collected and understand what that really means with respect to the building. Now, in more simplified terms, I thought it was important to understand what vibrations really actually mean. And vibrations originate as at a source. They transmit through a media, normally soil, and then reach a receiver, such as a building or a structure. Different buildings will respond quite differently to vibration input because of their differing mass, stiffness, material, and composition, right? Moreover, different sources generate ground-borne vibrations that transmit through the soil in different ways. Now, what that means for buildings is the magnitude of vibrations is typically measured in terms of peak particle velocity, or PPV. You will see this written a lot if you ever receive a vibration monitoring report. What this really means is it's a kind of measurement that measures displacement of inches per second. The number of vibration cycles in a specific period of time is called the frequency, which also is written very frequently in a vibration monitoring report. And I thought this was a good data to kind of see what are some of the common values of ambient vibrations, because for us, when we see vibration monitoring reports, not every value is disturbing. I think like it's easy to get lost in the many numbers that are written there. However, we should kind of note that the values that are in between somewhere 0.3 to maybe 1.2 are really the ones we should really be concerned most about. So in the context of construction activity surrounding a building, there could be various standards that are chosen where the PPV limits, the peak particle velocity limits, or thresholds are identified. Acceptable vibration limits vary significantly depending upon the type and the character of the structure under consideration. And you can see nearly all of the commonly used vibration standards recognize the need for lower vibration limits when dealing with older historic structures. I found 6 standards used in the US alone. So it could be very confusing. Here is a summary of the allowable construction vibration levels from these variety of references. And as you can see, there are significant variations on what's allowed, right? Some of the standards include different allowable vibration limits depending on the expected duration of the construction operation. So there are many factors at play. But the New York City guideline, however, which is also called as TPPN 1088, it contains a more specific recommendations for monitoring of historic structures, which are located within 90 feet of the new construction. This is a benchmark that is established to record and monitor vibration impact in this zone of 90 feet. Again, this can change if through the discretion of either the Department of Building official or the independent consultant or the engineer that the owner or the developer may hire. All buildings are required to be protected in accordance with these guidelines, the TPPN guidelines, when construction activities happen in the vicinity. The recommendations contained in the guidelines are generally appropriate for protection of the typical existing structures. The recommended vibration limit of 0.5 inches per second generally applies, but sometimes it does not appear sufficient to preclude damage in more vulnerable historic properties. And that's why the engineer that's hired, who's independent of the interest of the developer, can kind of establish a more appropriate threshold. And this thresholds can even be challenged by Department of Building officials. So this benchmarking of the thresholds of the PPV limits become really important in such projects. Another important aspect of construction activities adjacent to historic properties is handling movement. Ground displacement can actually happen as a result of excavation and foundation work and is a great threat. Foundations for the new structures are almost always much deeper than the foundations of the historic building, which may experience damage or displacement, even structural damage. Now, these graphics could be a little bit intimidating, but I will explain that the techniques that are used to prepare new foundations create potentially a lot of vibrations and sometimes dangerous vibrations. If pile driving is likely to damage adjacent construction, the contractor or the construction manager may be able to employ non-displacement piles that are inserted in bored holes rather than they are driven. So the photograph to the left kind of gave that example that these piles were not driven and were not hammered in the ground, rather they were drilled, they were poured in drilled holes, which are better in case there is a historic property in the vicinity. Lower vibrations can also be achieved by jacking in or pressing the piles into the ground. Once construction is complete, continual crack and vibration monitoring, like we discussed, provides an effective warning system indicating that the established safe thresholds have crossed. Again, like in all of the kind of written material, the thresholds, there is no one threshold given that's one size fit all. The thresholds can be changed based on the conditions of the historic structure. Efforts to control movement should actually begin at the consultation phase. The one photograph to the right, where the sequencing of the monitoring, and pretty sure these thresholds kind of established were not adequate, could result to severe failure. Whether the developer's engineer selects underpinning or strengthened excavation walls to protect the historic property, the means or the goal is to restrict movement of the adjacent structure. The historic building owner should actually retain their own engineer to review the plans proposed, right? Like in this slide, there are two methods indicated. The one on the left is a more of an underpinning method of the historic foundations. And in some scenarios, this is a good approach. In some scenarios where I have seen that the new foundations are significantly deeper than the existing foundations, these more kind of strengthened excavation walls or secant pilings with like rigid tiebacks are more beneficial because they contain the ground much better, which would resist the movement of the historic structure. This should approach, so whichever approach is selected, it should kind of ensure that the unique characteristics and vulnerabilities of the historic structure are protected, and any even incidental movement is restricted, because any movement any discernible movement is bad movement for the historic building. So after we talked about, vibrations, the movements, the concept, the management of water and possible dewatering of the site are very important. So the water drainage system, as is seen here, of the historic property can easily be damaged or rendered ineffective by neighboring construction or demolition work. There can be issues with debris clogging, the gutters and the downspouts, and the final landscaping and grading plans patterns on the adjacent construction sites should also be examined to ensure that the rainwater is not routed towards the historic building, which could be a scenario here. There is a huge landscaping around the existing historic building and a big new facility is being planned quite adjacent to it. And as you can see, there would be a lot of regrading of the site to accommodate the new construction activities. So some of the more kind of obvious things to note here would be, what are the final grades, and are we making the historic building more vulnerable by throwing water back at it? In some cases, however, lack of water beneath the historic structure can also lead to damage. Buildings that are located in areas with high water table were often constructed on timber piles or have foundations that are brick foundations. When groundwater or stormwater is removed from a neighboring site during foundation excavation, also known as dewatering, the ground level beneath the existing structure or the historic structure may also drop. Now, previously submerged timber piles that are exposed to air now because of the dewatering can quickly begin to undergo dry rot. This condition can be carefully examined by the consultant and actually should be red flagged. And it can be prevented by using watertight excavation support systems such as a slurry wall, which ensures that most of the water pumped out of the construction site does not come from adjacent properties. Now, another thing to note really quick is that the dewatering of the soft playground may also result in settlement of the neighboring buildings as the result of the ground water pressure is reduced and the soil kind of consolidates. This is somewhat less of an issue inside the New York City because there is so much bedrock around here. But even if we go somewhat a little bit outside of the main Manhattan area, this issue can become really important. Now, quickly talking about fire and safety, which become really important when the construction activities in the vicinity of the historic building are expanded due to schedule issues or expanded due to weather-related issues. The heightened possibility of fire accompanies really many demolition and new construction activities. The temporary heating devices, torches, sparks, molten metal, undersized utility panels, and some of the most common sources of fire that can be seen at construction sites. Improper storage of fuel also provides possibility of the fire to ignite and spread. Again, all these items really should be substantiated in the construction plan and should be reviewed by the historic building property owners, independent engineer, whoever this was provided by. The temporary protection that's provided by the scaffolds constructed should also not provide opportunities of illegal entry into the historic buildings, because we've seen this many times where scaffolds would just kind of expose the windows, or would expose a setback roof of the main roof area. And the new constructed floor levels at the building may make the neighboring historic sites, structures, ledges, windows, and other rooftops really accessible to, unwanted intruders. And that again should be listed carefully and picked up carefully during the construction plan. Another more obvious one is the physical impact, where the cranes, the hoists, the workers on the upper floors of the construction site can really drop supplies and tools onto the adjacent historic structure and cause real damage. And some of these things can become also, like whose responsibility would that fall into if there is damage that occurred due to some construction activity where it thinks that fell on some historic property's feature, then whose responsibility? It's important to identify responsibilities of issues that occur at site as the work goes along. Now, protective barriers should really be placed over any area of the historic structure that's deemed at risk. If the new construction will rise above the historic building, plywood sheets should be placed over the roof to distribute force of any dropped materials. Additionally, netting can be rigged to shield vulnerable features of the roof, or in this case, this was a standing seam copper roof, and it was supposed to stay in place. The facades that are directly exposed to the adjacent construction should receive close attention by boarding up the windows or scaffolding areas of the facades, and a high density debris netting should be placed on the scaffolds too. Now, this is a big one. Let's discuss this, what a monitoring plan is and what its role in the successful execution of the project is. Now, I looked at the Department of Building, and there are very many sections that are listed in the Department Building's codes where there are issues of structural stability listed in the code. And various sections, as you can see, substantiate how to record and report these plans to DOB, right? So a professional should be aware, whoever professional is hired to do this monitoring program should actually be aware of the Department of Building's mandate. The program should really be established during the consultation and documentation phase and continued until adjacent work is completely finished. It is undertaken to detect, gauge, record, and interpret structural movement and other changes to the historic building that can result from neighboring construction or demolition work. As we saw earlier, a vibration monitoring report generates a lot of data, and interpreting that result from the perspective of the historic building is really crucial to understanding what the risks are for the historic building features. The data collected during monitoring program can serve as a baseline for any subsequent movement or changes to the site drainage patterns that may arise within the first few years after the construction is completed. The monitoring also shows the degree to which steps are taken to protect the historic structure from the adjacent construction that are sufficient and actually successful. It's also undertaken due to liability concerns, as you can see, the support of adjacent property and underpinning. If the historic building foundations are exposed, this is a big liability concern. And that's why it's kind of advised that the engineer who should develop this scope of monitoring program
including the location and the type of instruments, the duration of the readings, the frequency of the readings, and the permissible movement and the vibration criteria, hence the thresholds. This should be an independent engineer, because otherwise, if it's the developer's engineer, their view could be biased. A basic plan to address the concerns over vibration levels may include a single seismograph placed on the structure's basement floor, or could be more comprehensive measurements that could be obtained by locating sensors at several points throughout the structures and ground immediately adjacent to the building. Like here in this slide, where we saw all the markings here that are, you know, M1 through M6 and 8, I guess, and here M1 through M10. They are placed in different areas of the structure depending on what they thought that would create as an issue. Whether acceptable vibration levels are mandated by the law or left to the discretion of the project engineer, the threshold should really be taken into account because of the surrounding soils, the makeup and the condition of the adjacent foundation, and the particularly vulnerabilities of the historic resource. In this Manhattan case, where, you know, the foundations are really on bedrock, it's a little bit less vulnerable. Not saying that it is not vulnerable, but there is one aspect of the equation which is somewhat working. Because if there are buildings that are already placed on, you know, somewhat of an unstable soil ground, it's just really a lot more vulnerable. The limit of the historic buildings will likely be in the range somewhere between 0.12 to 0.5 inch per second. As you saw, 0.5 is the threshold that's established by Department of Building, but we saw through our, you know, it could be somewhat non-accommodating to historic building materials that could be more fragile. So as an owner, a question to your engineer or a question to the building team of whether the thresholds that are being, you know, proposed, are they sufficient, is generally a good idea. For cases of extreme fragility, or where we have a very high importance factor, right? Like the building could be of a very high importance. The lowest vibration limit really should be set for the maximum ambient level of the vibration in the building. This level can be determined by monitoring the vibrations for a period of time. And these reports are generated periodically and very quickly. So if there are red flags, they should be really immediately picked up by the engineer. Now, this I thought was really interesting, since it's a multi-party, multi-consultant project. These projects tend to be very big, and there are many kind of, you know, parties involved. So the preservation guidelines, they publish a checklist for the historic property owner. It kind of, the checklist gives a lot of information about, did you consult with the developer? Did you conduct a survey? Was the historic building construction site fire plan included? So were the windows, rooftops, doors were secured? So I thought this was a very good checklist that could be referred by the historic building owner. There was also a checklist that was given for the development team and the construction site, where they obviously kind of recommend consulting with the historic property owner and other relevant parties. Some of the more important ones were, you know, limit the movement of the adjacent building. Again, like this can be kind of tackled in multi-part approach. One is giving protection to the adjacent building owner, but then also looking at the processes of the demolition and the other means and methods that are being used by the construction team, to look at that closely, whether they're sympathetic to the historic building materials in the vicinity. In conclusion, growth and development of the city are inevitable. We live in an ever-changing landscape of this continuous development. So that is going to happen, but through careful activities, through careful management of the activities, and providing a forum of discussion and an independent review can really make these developments happen in a more safe environment, and the protection of the historic resource of the city, which is crucial to our continual development, can actually be materialized. So that's how I wanted to conclude my presentation.
All right, thank you, Charu. Does anyone have any questions?
I do. This is Ross Lee.
Oh, hi, Ross.
Hi. Well, I just wanted to know, in typical cases like this, who bears the cost of the independent engineer? I guess it's the developer of the new building, right? Because the historic building, it would be totally unfair to them if they have to pay for this, these services. Although, if they really want to be, to be sure there's no conflict of interest, they might want to hire their own, right? I mean, so what is your experience?
So I worked on the Robert Ann and Dickey house where the developer owned the house and owned the adjacent properties that were demolished. However, they did not own the property that was adjacent to the previously adjacent properties. So the properties on the other side. In that scenario, the developer did hire their own engineer, but the other property owner, they kind of hired their own independent lawyer and engineer, and they bore the cost of their lawyer. However, their engineer's costs were back charged to the developer of this property. And these who bears the cost of the services can get a little bit complicated based on the insurance requirements and whose responsibility is what. But the technical services for this work usually comes from the developer, mainly comes from the developer. You're right, it is unfair for the historic building property owner to bear this kind of cost. Having said that, I also think that developing that kind of cooperative relationship with the new construction developer is very important, and actually in interest of the historic building property owner, because most of the times the extra vibrations that are induced causing issues in the historic building property can actually be fixed or corrected by the developer's team, because it's in their interest to kind of go through with this repair work and not undergo any delays in the construction schedule and progress, because really in these big projects, time is money, and they will be losing money if they're losing time. So it's better for them, usually good for them, to just go through with the repairs.
Mm-hmm. I mean, in my past project, I remember, well, we always recommend that the building owner document during the planning stage before anything happens. Document the building thoroughly, usually video and, you know, accompanied by drawings. And it's actually for the benefit of both sides, because if, you know, let's say a crack developed and the developer could say, well, that crack might have been there before, you know, but then there's proof that there was no crack before the construction. And so, you know, that I think that's a very good practice, you know, to follow.
Yeah, and I cannot stress that enough, that a pre-construction survey is really very important, and it becomes a real legal entity now, because and I've seen, you know, in early times, all the survey was done through hand and visual observation, and that practice still is there. But now I've also seen these kind of cameras that are kind of installed on the site, so they can actually see real-time activity from before the construction started to and during the construction to really after the construction. So there is a lot of transparency in the way the conditions of the buildings are recorded, and you know, you can actually see a lot of information on, you know, what activity produced what effect on the construction, on the adjacent construction. I think it's fascinating how much technology has changed in the way we, you know, record buildings for this purpose now.
Okay, are there any other questions? Anyone? All right, if there are no other questions, Charu, thank you again for your informative presentation. And thank you everyone for coming out this evening.
Thank you. Have an awesome evening.
Have a great night, everyone. Thank you.
Bye-bye.